Right, hello, this is your first session on Chemistry Year 10, and the topic is Atoms, Elements, Mixtures, Compounds, and an introduction to the periodic table. So here, as you can see, is the periodic table. It goes in order of atomic number. That is the bottom number here. So the bottom number goes 1, 2, 3, 4, 5, etc. And then at the top number is the atomic mass, and that also goes up in increasing numbers, but not in a counting order. So it goes 1, 4, 7, 9, etc. You will find a couple of areas when that number doesn't go up. So for example, if you go to argon, is number 40, and then potassium is number 39. So even though the atomic number, the proton number, goes up from 18 to 19. That is due to the number of neutrons and will be discussed in a later video. All of these are elements, and each element has the same type of atom within it. So for example, all of these are hydrogen atoms, lithium atoms, manganese atoms, etc. They all have the same number of protons within them. Each of these elements has its own symbol. The symbol for helium, for example, is He. You will find that the first letter is always capital, and if there is a second letter, it is always a small letter. If you wrote strontium as capital S, capital R, you would lose a mark in an examination, so make sure you're very careful with that. You are not expected to recall any of the elements, though you should be able to look at the periodic table and be able to identify elements from there. Since I said all of these consist of the same atom, so for example, all lithium atoms are the same, all cobalt atoms are the same, although cobalt atoms are obviously different to lithium atoms. That is what makes them elements. If you chemically bond elements together, you get a compound. So for example, you could have lithium joined with oxygen to make lithium oxide, magnesium joined to fluorine to make magnesium fluoride. And that then would be a compound. You could then take either elements or compounds and mix them together without chemically bonding them. That is important, and that would make a mixture. The difference between a mixture and a compound is that a mixture is easily separated by physical methods, whereas a compound you can only separate with quite a complicated method, usually using electricity. So that is what you have as far as the periodic table is concerned. If you're asked approximately how many elements there are approximately 120. You can see this element down here is 118 and is probably the largest one that we know of so far. The ones at the bottom here, where you will see have a number in square brackets for the atomic mass or the mass number. That means they are unstable and don't last for a terribly long time. Right. So the next topic, then, you need a few examples of these things, which you've seen already as far as the elements go. You may then have some compounds. So if you have a compound, a nice simple one, lithium fluoride. Lithium fluoride consists of one atom of lithium chemically bonded to one atom of fluorine. If you have something a little more complicated, say for example magnesium chloride, well, in this case one atom of magnesium is chemically bonded to two atoms of chlorine, and you can get more complicated again. For example, something like calcium carbonate, and that consists of one atom of calcium, one atom of carbon, and 3 atoms of oxygen. So if you wanted to write down the ratio of those things, it would be 1 is to 1 is to 3. So the ratio of calcium to carbon to oxygen is 1 is to 1 is to 3, and that would be the ratios. Now, obviously, the whole point of these things is to construct equations with them to represent chemical reactions. Now, a nice simple one would be something like lithium plus fluorine makes lithium fluoride. So let's write that out as a chemical equation. We would have, I'll do it as a word equation first. We would be lithium plus fluorine makes lithium fluoride. Now, at foundation tier, that would be pretty much all you would be expected to do. But as you're moving on to higher tier, you would be expected to write that as a symbol equation. So that would be lithium plus fluorine makes lithium fluoride. Now, as you can see, the reason we write it like this is that's how fluorine exists in the real world. Lithium exists as two fluorine atoms chemically bonded together. Lithium, on the other hand, just exists as individual lithium atoms, and lithium fluoride is one lithium joined to one fluorine. Now, you can see from this that they are not balanced. We've got one lithium on this side, which is fine, one on this side, which is equally fine, but we have two fluorines here and just one here. What we are not allowed to do is mess about with any small numbers at the bottom here. We're not allowed to do that. We're only allowed to double or treble or multiply by 4, 5, whatever, the whole thing here. So we can put a 2 in front of the lithium and a 2 in front of the lithium fluoride. So we've got 2 atoms of lithium react with 2 atoms of fluorine, a fluorine molecule, to give 2 lithium fluoride, well, we could say molecules, but it's ionically bonded. We really should say just 2 lithium fluorides. So to do something a little more complicated then, we could have something like calcium carbonate reacting with hydrochloric acid which will give us 3 things. It will give us calcium chloride and carbon dioxide and water. Now, once we have that, we've got to write out the structure of each of the chemical formulae. So that's CaCO3 plus HCl, and that gives us calcium chloride. Well, that happens to be CaCl2. Carbon dioxide, you should all be familiar with as CO2, and obviously water is H2O. That again is not balanced. You can see here there is just 1 chlorine and here there are 2. So we will have to double this up. 2 of those. So let's see if that works now. 1 calcium, 1 calcium. 1 carbon, 1 carbon. 3 oxygens, 1, 2, 3 oxygens. 2 H's here. And there's 2 H's here, and 2 Cl's, because this 2, remember, means 2 of everything, and 2 chlorines here, because the little 2, remember, means 2 only of the thing that it is directly behind. The last thing I'd like to just mention here is the changes of the names. So, for example, this here is fluorine, but when it joins to the lithium, it is now fluoride. So fluorine to fluoride. Hydrochloric acid gives us calcium chloride. You see this all the time, and you're quite familiar with names like calcium dioxide. We don't call it carbon dioxygen, we call it carbon dioxide. The same here, calcium carbonate. Calcium, carbon, and the 8 symbolizes that there are several oxygens joined to it. So that is how the name changes. That is all that we need to go into for our first session. What I'd like you to do, please, is follow the link on Show My Homework and go into the SAM Learning and complete the module that's there for you. Thank you very much.